Okay, we're going to finish up the year with a lesson on rational exponents. We've talked about this a little bit, the idea that if I have the square root of 16, say, that's the same thing as 16 to the 1/2. And where those numbers come from, the 1 is the power of this, of your radicand, and then the 2 is the understood root here. So in this case, it would be square root. So if I had the cube root of 8, that would be 8 raised to the 1/3. If you had the 5th root of x to the 4th, then that would be x to the 4/5. So we're going to do just a little bit of simplifying. I'm trying to keep it not too complicated, but just give you a taste of it before you head out to the next math class. Before we do what we're going to do, I think I do want to talk a little bit about powers of numbers like 16. You want to recognize that 16 is, we know, 4 squared. It's also equal to 2 to the 4th, because 2 times 2 times 2 times 2 is 16. So you want to understand 16 to a base of 4 and 2, and there's some other numbers, and they use several of them. I mean, you can have, if I have a 100, then nothing we're going to use is anything more than 10 squared. There's no other base that we're going to change that to. We can't write 10 is not a multiple of anything that will be a perfect square. But 81's a good one. 81, most of the time we're used to 9 squared, but 9 is think about it, 9 is 3 squared, so you can actually break 81. If you do its factor tree all the way down, it's 4 3s. So it's also 3 to the 4th. And then another one you might see is, and I'm going to keep the numbers fairly small, but those are probably the most common ones. I was looking to see if there was any other one that wouldn't be just a straightforward, easy root. 64 is a good one, because 64 is, we know, 8 squared. 64 is also 2, let's see if we do, probably the easiest way to be do the factor tree of it. So I can do, left one of my 2's off here. See, I've got 4 to the 3rd power. 4 times 4 times 4 is 64. I've got 3 2's, so that's my 8 squared. And then I've also got 1, 2, 3, 4, 5, 6 2's, so it's 6 squared. Try that again. 2 to the 6. I've got 6 2's. So keep this handy as you're working some of these. I think it'll make sense to you, because we're going to take it from this format and we're going to go to the simplified format. So let's start with, let's do 64 x cubed raised to the 1/3. Okay, we know that powers of a power, if we need to review that, if you have, a to the 5th raised to the 3rd, that's a to the 15th. That's the product of the exponents. So this is going to be 64 to the 1 raised to the 1/3. And that's going to be x to the 3rd raised to the 1/3. So it's 1 times 1/3 and 3 times 1/3. Now we're going to come back and talk about this one, but 3 times 1/3 is just 1. So I've got x, or x to the 1. Now let's see what we can do with 64 to the 1/3. Now look at your denominator. And if we go over here and look at 64, we know that 64 is 4 cubed. So if I take 4 cubed and put it in place of the 64, look what happens. See, I'm putting 64 as 4 cubed. Well, 3 times 1/3 is 1, so I've got simply 4x. We're taking the cube root of 64, which was 4, and we're taking the cube root of x, and that might be of x cubed, and that might be the easiest way to say it. Let's do 100 m to the 4th raised to the 1/2. Okay, that's going to be the square root of this one and the square root of that one. But again, when you work with them as rational exponents, if you'll think about it with your laws of exponents, you're just multiplying exponents. So the only thing I can do with my 100 is it's 100 to the 1/2, and 100 is 10 squared raised to the 1/2. See, I'm just substituting something that will make the arithmetic easier here, and then m to the 4th raised to the 1/2. So if I multiply 2 times 1/2, I get 1. So that's just the square root of 100, square root of 10 squared. And then m to the 4 times 1/2, well, 4 times 1/2 is 2, so that's going to be m squared, because the square root of m to the 4th is m squared. Okay, number 3. Let's do, let's see what we've done. Let's do 81 m to the 8th raised to the 1/4. So take your 81 and look at it, and which one, what can you rewrite 81 as? You can rewrite it as 9 squared, which 2 times, it'll be 2 times 1/4 as your exponent. But here's the one you want, because if I write 81 as 3 to the 4th raised to the 1/4, see, I'm raising everything in here to the 1/4, then 4 times 1/4 is just 1. And then m to the 8th raised to the 1/4. So the 4th root of 3 to the 4th, that's what it's really saying. 4 times 1/4 is 1, so I have 3 here. And 8 times 1/4 is 2. So I have 3m squared. Taking the 4th root of each one of those. And they really want you to leave them as exponents, because there's more things you can do with them as exponents than radicals. You'll see those more in a college algebra pre-cal class. Let's do 49 a to the 6 raised to the 3/2. Okay, well, the only thing I can do with 49 is 7 squared raised to the 3/2, and then a to the 6 raised to the 3/2. Okay, let's multiply those two together. What is 2 times 3/2? Well, your 2's cancel, and you're left 7 to the 3rd. And you're multiplying 6 times 3/2. And the 2 and the 6 cancel, and you're left 9. And then 7 times 7 times 7 is 343, a to the 9th. Okay, let's see if I've got any other good ones. Okay, let's do this one. Let's do 125 m to the 9th raised to the 4/3. Okay, 125 you should recognize as 5 cubed. Okay, those are just powers that you need to know. I'm going to stay away from the big ones, but that's probably about as big as I would use. And then times, and then m to the 9th to the 4/3. Okay, well, let's multiply these two. 3 times 4/3, the 3's cancel and leaves you 5 to the 4th. 9 times 4/3. 3 goes into 9 3 times, and you're left with 3 times 4, which is 12. So you've got m to the 12th. And then go one more step. 5 to the 4th is 25 times 25, which is 625 m to the 12th. And that's probably I think those are good enough that'll help you as you're working your classwork. Don't forget your responsibility points. You need to type me a paragraph with at least 3 sentences, complete sentences, spelling correctly, about your experience with your online math class. It's been a great year. Thanks.